A hot axle box in a railway vehicle occurs when inadequate wheel bearing lubrication or mechanical flaws, such as bearing failure, cause an increase in temperature. If left undetected, the bearing temperature can continue to rise until there is a bearing burn-off, which may lead to a derailment. A hot axle or hot box is the term used when an axle bearing overheats on a piece of railway rolling stock. The term is derived from the journal bearing trucks used before the mid-20th century. Hot axle arises due to overloading and faulty conditions of the bearing. During a hot axle incident, the wheel becomes very hot, and the movement of the train may stop sometimes if the jamming of the bearing happens. Let's learn the different components of cartridge tapered roller bearing. Cap screw, locking plate, end cap, seal wear ring, grease seal, cone assembly, spacer, and cup. Inside the cone assembly, there are three parts: roller, cage and cone. Bearings are manufactured with all the components pre-assembled. Additionally, an axle end cap, a locking plate, and cap screws are provided with each bearing. Causes of hot axle. The following can be the reason for hot axle: defects in lubricant like bad quality of grease, excessive quantity of grease, non-availability or inadequate quantity of grease, and foreign material contained within the grease. Mechanical disorder like defects in the journal, defective bearing, defects in the axle box, broken cage, oozing out of grease due to perished rubber seals. Irregular loading such as uneven loading, overloading, and some miscellaneous. Reasons are incorrect fitment, improper mounting, improper handling, excessive temperature or heating, excessive or uneven loading, and impact loading. There are different technologies has been incorporated for the identification of hot axle. Rolling in examination is one of them. Rolling in examination, the train examining staff shall take up positions on both sides of the line short of the platform on which the train is to be received. This will enable them to observe the condition of the running gear as the train passes, and they will also be able to note defects such as flat places on tires, hot axles, broken springs, defective brake gear, etc. Appropriate action on such defects shall be taken thereafter. These on-screen checklists need to be taken care while observing the rolling in examination. These will help us for easy identification of symptoms of hot box. Non-contact infrared thermometers are widely used in Indian railways to monitor the axle box temperature. The table shown here are the special instructions for axle box feeling of coaches. This table demonstrates the special instructions for axle box feeling of wagons. The two technologies which are widely used in Indian railways for the automatic detection of CTRB failures are Hot Axle Box Detector or HABD and Railbum. Hot Axle Box Detector, Hot Bearing Detector, sometimes also known as a hot box detector, is a technology that monitors the bearing temperature as the train passes by. Detection is achieved on a real-time basis so that a hot bearing can be traced, monitored, and an alarm can be raised if the temperature exceeds the alarm settings. Railbomb is an acoustic-based axle bearing defect detector that provides early warning and trending of bearing health, which could help on preventing future bearing-related catastrophic incidents. The both systems works automatically and send alerts and to control centers and messages to mobile phones of concerned officials. Let us discuss the preventive measures to be taken at ROH sheds, SICK line to avoid hot axle. The earthing in wagons for welding should be done properly and very close to the welding area so that electric current does not pass through the bearing, causing arcing between the rollers and raceways, leading to failure of CTRB. The lateral play of the bearing must be checked each time, and ultrasonic testing of all axles should be done. Do not reuse locking plates. All tabs of the locking plate should be properly bent up against the flats of the cap screw heads. End cap screws should be properly tightened with the help of a torque wrench at a specified torque of 40 kgf. Load wear zone area of the bearing must be changed during fitment. Damaged outer cup bearings should not be allowed in service. It must be ensured by stamping particulars of the grease seal that the CTRB would not complete more than 72 months by the time it becomes due for the next POH or ROH. Overhauling cycle of new CTRB to take place at a 72-month interval. Let's see the duties of different railway departments as a preventive measure to avoid hot axle. Duties of station staff. Check for any symptoms like smell, smoke, whistling sound and flame while train passing. Exhibit hand danger signal immediately. Put back the departure signal. Advise loco pilot through VHF set to stop examine the train. Alert the gate man in advance to stop the train. Advise the controller to arrange to stop the train as early as possible. Advise the station master of station in advance not to allow any train in section in opposite direction. Duties of train crew. Look out while running on curves for any symptoms unusual. Stop the train by first means. Examine the affected vehicle. Exercise your discretion and take decision. Guard should watch carefully the signals exhibited by station staff, gateman, gangman, other railway staff and act immediately to control the speed. Duties of P-way and signal and telecommunication staff. Be vigilant while train is passing through in section. Inform about any unusual noticed in train to the nearest station master or controller. Show danger signal and try to alert the guard by shouting or waving. Arrange to stop the train immediately. Duties of gateman. Watch the passing through trains carefully. Exhibit danger signal and alert the guard to stop the train immediately. Advise the station master to stop the train immediately. Duties of section controller. Arrange to stop the train if hot axle on train is reported by field staff and station staff. Inform to concerned departments and get it examined by guard and driver or station staff. Train should be stopped and checked as soon as any of symptoms noticed. Such trains should be allowed to enter station only after it is checked. Duties of C and W staff. Carry out carefully rolling in and rolling out examination on all trains at nominated stations or yards. Feel the axle boxes immediately with non-contact temperature measurement gun on arrival of trains. Detach the vehicle if hot axle is noticed.
Welcome to our video presentation on automatic twist locks for container wagons. This video is presented by Team SG, South Western Railway, Bangalore Division. The innovation of automatic twist locks revolutionized the shipping industry. Let's dive in and explore the world of these remarkable devices. Container wagons are an integral part of modern freight transportation, allowing for the efficient movement of goods across vast distances. But how are containers secured to these wagons, ensuring their stability during transit? That's where automatic twist locks come into play.
The automatic twist lock, ATL, is the compact container locating and securing device invented and patented by M.S. Holland & Co. These locks are fitted on low-platform container flat for securing the containers. Unique feature of this lock is its locking and unlocking is automatic, fitted at the locating points of underframe sole bar of the flat wagons. Steel torsion springs were provided in their internal mechanism in new version of ATL devices. These locks are designed to lock the containers with the wagons with a force of 800 pounds. It unlocks the container from the wagon with a force of 1,600 to 2,200 pounds.
Hi friends, this is the ATL lock, automatic switch lock, which is in assembled condition. We can see from here that this is the twist head, upper housing, this is the lower housing, torsion spring, twist head shaft. Now let's see the parts inside this. We can disassemble this ATL lock. We know that the ATL twist head is connected to twist head shaft by the groove pin. So groove pin is this. This is the ATL twist head. This is the twist head shaft. So there is a external spacer between this upper housing and the ATL head. Then the upper and lower housing is connected with 4 torque screw, hexagonal torque screw. So we can remove that. Here we go. So this is the upper housing. This is the twist head shaft. Actually, the head is folded by the twist head shaft and it is folded by the torsion spring. So this is the shaft bearing sleeve and internal spacer. See, this is the shaft and this is the torsion spring. Torsion spring is connected to lower housing with locator pin. So we can remove that. This is locator pin. This is fixed. So these are the parts. Friends, now let's see how we can assemble this. This torsion spring is inserted through this. There is a hole. There's a hole here. This hole will go through the pin. Now this is the twist head shaft. We can place this here. Then internal spacer, shaft bearing sleeve. Then upper housing will come. Then torsion screw, external spacer, ATL twist head, finally the groove pin. Thank you.
When the container is loaded on this ATL, the container will first touch this portion and this portion, and it will be rotating the lock in this direction like this, and container will sit in this portion and the lock will again come in this orientation only. Again, when the container is unloaded, it will sit in this slot from one side and in this slot from other side, and when this is lifted, the lock will come in this horizontal position, and when the complete container has unloaded, it will again come to this original position after unloading.
down dia marah.
The Automatic Twist Lock, ATL, is a compact device patented by M.S. Holland Co. It is specifically designed to secure containers on low-platform container flats. The ATL stands out for its automatic locking and unlocking mechanism. These locks are installed at the locating points on the underframe sole bar of the flat wagons. Their purpose is to secure the containers to the wagons with a force of 800 pounds. When it comes to unlocking, the ATL requires a force of 1,600 to 2,200 pounds to detach the container from the wagon. In the context of Indian Railways, there are three types of wagon groups equipped with ATL, namely BLL, BLC, and BFKN variants. Guidelines for inspection, maintenance of Holland design automatic twist lock fitted on BLC, BLCM, BLL wagons. Inspect for availability of all locks. Inspect the wagon and see if all the 8 automatic twist locks, 10 in case of BLL, are in place. If there is any deficiency, provide a new automatic twist lock and weld the same after correct positioning as per RDSO drawing. As you can see, slidging lock assembly is missing here. Check for ATL proper functioning. Rotate the twist head back and forth. Normally there is slight loose play due to clearances. High spring resistance is encountered and it is very difficult to turn the twist head more than 15 degrees by hand. If the twist head easily turns more than 15 degrees by hand, then the torsion spring or locator pin need replacement.
Torsion spring is connected to lower housing with locator pin. So we can remove that. This is locator pin. This is fixed. So these are the parts. Friends, now let's see how we can assemble this. This torsion spring is inserted through this. There is a hole. So hole here. This hole will go through the pin.
In case the locator pin is rusted or corroded or broken, then drill through the outside of the lower housing at the round tack weld with a 3 by 8 inches drill. Drill approximately 1 by 8 inches deep to remove enough of the tack weld so the existing locator pin may be lightly hammered out and removed from the lower housing assembly. With a hammer, tap in a new locator pin so that it projects 3 by 8 inches to ½ inches past the internal diameter of the lower housing. Tack weld the locator pin on the outside of the lower housing. Reassemble the twist lock with correct orientation of the torsion spring and upper housing assembly. Check for availability of twist head. As you can see, ATL head is missing here. Visually check for the damages of ATL, brackets, structural damage. Dimensions to be maintained for lock positions. Maintenance depots, workshops should inspect and ensure dimensions 19+0, 0, 1.0 mm is strictly maintained at all lock positions as shown in figure. For any variation in dimension need to be corrected as per RDSO drawings. The twist lock should not be lubricated. Using oil can harm the internal rubber spring and also affect how the lock engages and releases the shipping container. This can lead to the lock not meeting the AAR requirements.
What is GDR in railways? Guard and driver, GDR, check has been introduced to take care of an eventuality that the rate, which is to be offered for examination after completion of the loading and unloading cycle is required to travel for another 300 to 400 kms before hitting the first TXR point in the direction of movement. In the case of container rates, there are some additional areas where special attention needs to be paid during the GDR check. In this video, we are attempting to highlight what those areas are. Ensure that all loaded containers are securely locked with ATLs at all 4 corners, with one ATL at each corner. If any deficiencies in the ATLs are noticed, it should be promptly communicated to the CWC personnel. In this picture you can see that ATL set is missing. Check that the ATL twist heads are properly engaged at all 4 corners of the containers. This is how an improperly seated container looks like. Ensure proper seating and engagement of rotating and sliding lock brackets. In use position and not in use position. Here rotating lock placement is correct. Look here, you can see rotating lock placement is wrong here. Here sliding ATL lock placed wrongly. Here sliding ATL lock placed correctly. Inspect the seating of the center pivot of the wagon. There is a possibility of the center pivot becoming disengaged during container loading and unloading operations using cranes. The GDR should carefully examine the center pivot to ensure it is properly seated and not dislocated. In this picture you can see normal seating of center pivot. Here, as you can see, center pivot of the wagon got dislocated. Let's go through some images of damaged automatic twist lock. We have made an effort to include specific areas related to container rates equipped with ATL locks in this video. We hope that it will be useful for guards and loco pilots when conducting a GDR check. Apart from the sections mentioned in this video, all criteria listed in the Camtech pamphlet regarding the checklist for GDR checks should be fulfilled during the inspection.